Question 6. So before we can differentiate, it's just simplest to tidy this up. So start off by multiplying out the pair of brackets, which I've done here, and then divide each term by our 2x, giving us these four values here. So I haven't done any differentiating yet. This is all still y equals. Now this is now in a fit state to differentiate, so we do so. So for each term, multiply by the current power and reduce the power by 1, giving me dy dx being this. I guess the last one's the only slightly complicated one. Multiply by the current power, so minus 1 times minus 6 is plus 6, and then reduce the power by 1, becoming minus 2. Now for part B, we've got to find an equation of a tangent, so we're going to end up needing to use the big formula y minus y1 equals x minus x1 down here. So what do we need? We need to know a point on the line, and we need to know the gradient. So we know when so to find the point on the line, we know we know the x coordinate is minus 1. So substitute this into the curve itself to get, and that allows us to work out what the y value is. So we're substituting minus 1 in here. So we've got minus 1 squared plus 4 multiplied by minus 1 minus 3, and that's over 2 lots of minus 1. So we've got 5 times minus 4 up here. That's supposed to be a minus 1 there. It's not very clear. That's minus 1 minus 3. So we've got minus 20 as the numerator, minus 2 as the denominator, giving us an answer of 10. So our point on the tangent, our point C, is x being minus 1, y being 10. Now to work out the gradient of the tangent, we know that we substitute the x value into the curve. So we're going to substitute this into, not into the curve, we're going to substitute this into the differential. Because remember, the differential allows us to work out the gradient at any part of the curve. We want to know the gradient of the curve when x is minus 1. So we substitute minus 1 into the differential. So we're substituting that into this. So minus 1 minus 3 over 2 plus 6, really 6 over minus 1 squared. Remember, 6x to the minus 2 is 6 over x squared. So simplifying out each of the three terms and adding them together, we get the gradient being 7 over 2. So I'm now in a position to substitute this into our formula. So y minus y1, well, our y value is 10, equals m, the gradient, 7 over 2, x minus x1, so x minus minus 1. Now remember, x minus minus 1 is plus 1. I've then chosen to undo this dividing by 2, so I've multiplied through by 2, so I've got 2y minus 20 equals 7x plus 1, multiplied out the bracket, so my right hand side is 7x plus 7, and then given that we need to give the answer in this formula, I've taken it all over to the right hand side, so I've got 7x minus 2y plus 27 equals 0.